Assalamualaikum, my name is Nurin Binti Muktar. So now I will present about the background of the project. Boolean algebra is one of the branch of algebraic mathematics that deals with binary numbers. So in Boolean algebra, we have Boolean operations and Boolean expressions. If we use large number to perform Boolean operations, we will have difficult time, especially if the number is not in the binary number, because we have to convert it first. So the existence of Boolean calculator can help us to find true value easily by just key in the variables, the number that we want, and then the Boolean calculator will return the truth value. So in this project, we extend the capability of ordinary Boolean calculator to perform geometric calculation, which is to calculate the parameter of shapes. So the calculator in this project not only can perform Boolean operation but also can calculate the parameter of shapes. This is our proposed design. So in this proposed design, we have project component, project flowchart, and interface design. For project component, our calculator will have two components, which is Boolean calculator and geometric calculator. Under the Boolean calculator, we have four sub operations. They are AND operator, OR operator, NOT operator, and XOR operator. For geometric calculator, we have square perimeter to calculate the perimeter of square, then rectangle perimeter and trapezoid perimeter. This is our project flowchart. So at the most left side here is the main menu, and at the middle is the flowchart for the Boolean calculator, and at the most right side here is the flowchart for geometric calculator. So this is our interface design. We just roughly do the outline for the output. So this is the main menu output, expected main menu output. And then this is for the Boolean calculator menu. And then at the right side here is the geometric calculator menu.
Assalamualaikum, my name is Ikhwan bin Mazlan, and I'm going to present about the Boolean calculator procedure or the Boolean calculator parts in our code. Alright, so first of all, we're going to move to the AND procedure. So in AND procedure, what we do is we ask the user for two hex value, and then we implement the AND operation on both the hex value. So let's go line by line. So first of all, in line 186 until 189, we display the name of the operation. When the user choose the AND procedure, and then the AND procedure will display the name of the operation itself, which is the AND operation. And then we ask the user for the first hex value using the read hex, and then we move the value from EAX into EBX, and then again we ask the user for the second hex value, and then we continue with the operation, which is put AND EBX and EAX, and then the resulting value we will display as the results using the right hex. Right, and then we're moving on to the OR procedure. Okay, for OR procedure, basically it's the same as the AND procedure, but then the only difference is we're using OR, not AND. Alright, and then we move to the NOT procedure. For the NOT procedure, first we display the name of the operation, which is the NOT operation, and then for NOT procedure we only ask for one hex value, which is to undergo the NOT operation. Okay, and then the resulting value will be shown using the right hex. And then the last one is the XOR procedure. So for the XOR procedure, first we will display the name of the operation. Okay, the same as the previous procedure, and or and not, and then we ask the user for the first hex value. Okay, using the read hex, and then we move the value from EAX into EBX, and then we ask the user for the second hex value using the read hex too, and then from there we use the XOR for EBX and EAX, and then the resulting value will be shown using the right hex. Alright, so basically that is for the Boolean calculator part. Thank you very much.
I am Nurin Sofia and I will present about geometric project code. So this is the figure that shows the procedure for calculating square perimeter. When the user enter the value, it will automatically stored in register EAX. For square shape, the length for each side is the same. So we assign the value stored in the register EAX to variable side length. Register ECX is used as counter to loop label 1. In label 1, the value in register EAX is added to the value in side length, and the result is stored in the variable side length. This statement will be looped until value in register ECX is equal to 0. The latest value in variable side length is assigned to register EAX, and right tag is called to display the result in decimal format. Next is for rectangle shape. The value entered by the user will be automatically stored in register EAX. For rectangle shape, the length for each length side is same and the width for each width is same. So the first integer, which is the width value, we assign the value stored in the register EAX to variable width x. For the second integer, which is length value, we assign the value stored in the register EAX to variable length x. Then we add the values and the result is assigned in register EAX, and right that is called to display the result in decimal format. Lastly, for the trapezoid shape, when the user enter the value, it will automatically store in register EAX. And for the trapezoid shape, the length for each side is different. So for the first integer, which is the first side value, we assign the value and stored in register EAX to variable side 1. For the second integer, which is the second side value, we assign the value stored in register EAX to variable side 2. And the third integer, which is the first base value, is assigned to variable base 1. And the fourth value, which is the second base value, is assigned to variable base 2. Then we add all the values and the result is assigned in register EAX, and right that is called to display the result in decimal format. In conclusion, assembly language can be used to solve logical and arithmetic problems. We use assembly language in this project and apply various IRVIN32 library procedures to achieve the correct output of each calculation performed and menu displayed. In this project, we have successfully used assembly language to perform Boolean operation and geometric calculation. Boolean calculator is useful for users to get instant truth value of 32-bit hexadecimal value by simply keying the values. While geometric calculator is useful for users to get the parameters of shapes that we offered for user to choose by keying the length of the shape size. That's all from our group. Thank you.
Now I will test the program for the demo, and now we start with the Boolean calculator. There is 4 options for Boolean calculator. It is AND, OR, NOT, and XOR. First one I check AND, and enter the first 32-bit hexadecimal. I test with 65 and 95. It says the answer is 05. Now we test with the calculator, hexadecimal, 65 and 95. Yes, it's 5. The first one is correct, and then the second one, we test again with 65 and 95. 65 or 95. It is F5. And then not X. If we choose 3, it is for the calculator for Boolean not. And if we check with 65, and then if we not 65, not, it is FFFF9A. Okay, it's correct. And then the last one is XOR. And the first is we use 65 and 95 again. If we check here, 65 XOR 95, it is F0. And for the Boolean calculator, it's already done. So we move to the geometric, and we should exit first. Exit, and then we can move to the geometric calculator. And there are 4 perimeter calculator, and square, rectangular, and trapezoidal. And if we choose square, we just need to enter the length of the square. If we input 6, it will return the perimeter of the square. And for the rectangular, the program will ask you about width and length, and it will return the perimeter. And for the trapezoidal, it will ask about 2 side and then 2 base for the trapezoid, and it will return the perimeter of the trapezoid. And if we want to go back to the main menu, we just use exit. And if we're done, we just exit from the main menu. Thank you, Doctor.